Toxicity within a species often contributes to unique colorations, markings, and morphologies to warn predators. But why is this the case? The story of the monarch's evolutionary arms race with milkweed provides an interesting case of cautionary phenotypes coupled with selective pressures derived from predation. As mentioned in our STEM chapter, the monarch larvae have unique internal morphological distinctions to enable the processing of toxic cardinalides in milkweed. Even though milkweed monarchs became poisonous after many generations consuming and retaining milkweed toxins, predators lacked considerable knowledge of the butterfly's danger. The result of this relational balance was a zero-sum game. Monarch larvae continued to die in droves, whilst predators would become ill or die themselves when consuming the caterpillars. As with many natural inefficiencies, a series of mutations helped pave the way for a new evolutionary trajectory, both within the monarch and related predatory species. In order for predators, mainly birds, to know that monarchs are dangerous to consume, distinct and recognizable morphological traits would provide a strong adaptive advantage to reduce incidents of predation. When examining the world of toxicity indicators, bright and vibrant colors are particularly common. For example, many species of highly toxic tree frogs are brightly colored in either red, yellow, or blue hues. Many predatory groups have undergone behavioral evolutionary changes in their sensory systems to recognize bright colors in prey as evidence of toxicity. The specific name for this form of behavioral coevolution in predators is called taste aversion, and in the case of monarch predators, it has culminated through the intersections of several modifications to the predator's sensoritory system. Monarchs followed a convergent evolution to that of poisonous tree frogs. In both larval and adult stages, distinct colorations have evolved to deter predators through taste aversion, namely bright yellow stripes on the caterpillar and distinct orange wings in the adult. The historical relationship between milkweed and monarchs has caused a sort of miniature evolutionary cascade, affecting not only these two species, but also an entire range of predators whose ancestral populations gradually acquired deterrence behaviors in response to negative consumption experiences. Not only did monarch-milkweed interactions create widespread color-based deterrence mechanisms, but also coincided with the unique evolution of a nearly identical mimic, the viceroy. Despite the uncanny similarity of these two butterflies, the viceroy comes from an entirely different genus of butterflies, the Limonitis genus, consuming an entirely different range of host plants. Interestingly, the viceroy of today is equally toxic to that of monarchs, thus begging the question of why this species bears such a strong resemblance to the monarch. When tracking the fossil record, it appears that monarchs and viceroys followed a path of Mullerian mimicry. This type of mimicry occurs when similar phenotypes, such as coloration and markings, evolve in a similar trajectory between species. In the case of monarchs and viceroys, black and orange wings appeared to have demonstrated greater selection potential in both butterflies. As a result of taste aversion evolution in predators, the rejection of orange coloration in one species likely influenced the success of orange phenotypes in the other, eventually yielding the uncannily similar butterfly species we know today.